Yes, we can do. We're live now.
Hello, everyone, and welcome to the DMS Real Talk 2022, a new and special feature of the UE Virtual Math Fair. The UE Math Fair encourages students to view mathematics in an exciting way and hopes to spark an interest in the field. Despite what some people may tell you, mathematics is far from dull. There are plenty of fun and strange mathematics facts out there that will fascinate children of all ages. Here's one to start you off. 40 is the only number that is spelled with its letters arranged in alphabetical order. So I'd like to introduce today's first presenter. Bringing greetings from the Ministry of Education and the speaker address is Mrs. Nicole Harris-Nutt. She is a curriculum coordinator in the Curriculum Planning and Development Division. She began her career as a teacher of mathematics at the secondary level before moving through the ranks to become an acting curriculum coordinator in the Ministry of Education. Welcome, Mrs. Harris-Nutt.
Good morning. Good morning, everyone. Good morning, everyone. I am going to be sharing my screen, so I am setting it up now. Ms. Diyanath, can you please let me know when my screen is up and sharing?
We are not seeing it yet.
Okay.
So just give us a minute.
Are you sure? Are you seeing my screen now? Because the...
Yes, we can.
Pardon me?
Yes, we can.
Okay, great. So, welcome to the DMS Real Talk, the UE Virtual Math Fair for 2022. Virtual mathematics. Yes, it is real. My name is Nicole Harris-Knudsen from the Ministry of Education, and I'm here with the Department of Mathematics and Statistics for today's Real Talk for the UE Virtual Math Fair. So here we have the only way to learn mathematics is to do mathematics. This is a quote from Paul Richard Harmos, who is a Hungarian mathematician who is American. So he has said what we are saying all along. We cannot do mathematics, we cannot learn mathematics unless we are involved in mathematics. Why host a virtual mathematics fair? Now, the University of the West Indies has modeled something wonderful for our students, for our teachers. We can inspire the creation of mathematics clubs at schools. We can showcase students' individual talents. We can develop students' self-esteem and their acumen. We can encourage students to navigate their virtual environment. We can foster relationships with schools as external stakeholders. The University of the West Indies, their clientele would be students who are at the tertiary level. This virtual mathematics fair is extended to secondary school students. So these reasons here would also apply to teachers and to students. So at your school, you too can have a virtual mathematics fair. Especially with the backdrop of COVID, we know that learning does not stop. And with our optimism, we recognize that we can still build capacity, ability, engagement of our students with a mathematics fair at the school. The University of the West Indies has shown us how. Now, for those of you who are mathematics enthusiasts, what would be your career path? Well, what we do know is that there are many, many paths that you can choose with a background in mathematics, with a foundation in mathematics. Mathematics-based careers include being an actuary, being a computer programmer, being a data analyst, an economist, an educator, an engineer, a financial analyst, a statistician, and the list goes on. So if you are a math enthusiast, there is a world out there waiting for you where careers abound, or the best on your journey. So to get there, where do we start? Mathematics does not stand alone. Mathematics is a tool to navigate our world. So if we think of stream education, where we are integrating mathematics with some other area or subject in education which you have an interest in, which you have an affinity for, you can link mathematics with science, technology, research, engineering, and the arts. So at your school, you should have a stream club developed where you can build your skills across the curriculum in other subjects where you apply your mathematics, where you use your tool, your mathematics as a tool for problem solving and for engagement. Where would this take you? Well, at the secondary level, the curriculum involves the lower secondary curriculum, forms 1 to 3, with a National Certificate of Secondary Education for mathematics. There are other subjects, but today we are focusing on mathematics. At the upper secondary level, there is the CXC-CSEC curriculum, where additional mathematics and mathematics are assessed. As we move forward, there is the upper secondary level where we're now going to the advanced level with the CXC CAPE, the Caribbean Advanced Proficiency Exam, where applied mathematics and pure mathematics are assessed. Now, to be honest, there is also the integrated mathematics. You are free to do this course should you choose. However, because of our ministry's policy, where we're looking at A-level courses, which would carry 2 units, the integrated math is not one of the subjects that is prescribed. However, should a student choose to do the integrated math, they are allowed to do so. Now, if you know where you're going, your path should be clear. So while you are at secondary school, you need to consider excellence. Excellence as a process. Excellence in your process. Excellence always. Lower secondary, upper secondary, you will be assessed and your certification will have some weight in your future. So Once you have passed through the secondary, now you can move on to tertiary level or higher education. Now, tertiary level takes on many forms. Today, we're looking at the University of the West Indies because they are hosting the Math Fair, and we want to expose you to the products, to the services which they offer. Now, in Trinidad and Tobago, education is free at the secondary level. So you are not expected to pay for your tuition. Now, let's be honest, there are costs that come up as you are progressing through the system. However, to attend a school, to sit in a classroom, and to access instruction, this is free for all students. When you get to tertiary level, it is different. The Ministry of Education has provided support financially for students to attend tertiary level classes. And these supports include the Financial Assistance Studies Program. This is a grant from the Ministry of Education. The Government Assistance for Tuition Expenses GATE program. This you can access information from the Funding and Grants Administration Division of the Ministry of Education. There is the Higher Education Loan Program, HELP. This is a soft loan facility from the Ministry of Education. Then there is the National Bursary Program. This too can be accessed at the Scholarships and Advanced Training Division from the Ministry of Education. And finally, there is the National Scholarship Program, which is also accessible from the Scholarships and Advanced Training Division from the Ministry of Education. Now, in saying this is accessible, I'm speaking about information which you can access. Even now, whether you're in Form 1, Form 2, Form 3, whatever your goal is down the road, you should be making a plan even now. Therefore, you must also consider how you will fund your tertiary expense and not only what is the path you will take. So at the secondary level, you sit with your teachers, you sit with your guidance counselors, and you work out what are the subjects I would like to pursue. And hopefully, should you choose to pursue a career in mathematics, you will be moving on to higher education at a tertiary level institution, just like the University of the West Indies. However, you then would be considering, how do I fund the program I would choose to enroll in? And there are options as listed on the screen from the Ministry of Education. Now, when you access information from the Ministry of Education, these scholarships may not only come from the Ministry of Education, but throughout a calendar year, there are other funding institutions that will provide grants which will help to support you, given that you have satisfied the required criteria. One of these would be the Ministry of Education, one of these would be the University of the West Indies, which offers bursaries to students based on criteria. Now, because we are talking about mathematics and we are talking about mathematics-based careers, then we look to the university for what programs they do provide. The university provides programs in actuarial science, mathematics, and statistics. Now we're at this point, we're talking about a virtual environment. Is it real? Students, we have seen that during the COVID pandemic, there were challenges and obstacles which would have slowed down rates of learning, which in some cases would have shut students out partially based on their access to devices and internet. However, we have to consider the steps that the university has taken so that even in a virtual environment, there is the reality of achieving our academic goals. The University of the West Indies has set up this virtual math fair in the face of COVID. For the first 2 years, the math fair was face-to-face, where you were able to go to the campus and see all the lovely displays. However, for the past 2 years, with the background of COVID, the University of the West Indies did not falter, and they did have the math fair in a virtual environment. Yes, this is our reality, and yes, it is real. So we thank the University of the West Indies for inspiring us, for fostering that relationship with us as external stakeholders, for providing us with a model which we can use at our schools to engage our students and build their acumen. It is exciting, it is engaging, it is competitive, it is lively, it is all that we want for our learners, where learning is fun, even at the secondary level. So, here we have Dr. Indra Harak Singh. She's the recipient of the Hummingbird Medal for her service in education, and we say congratulations to Dr. Harak Singh. We take this opportunity. Many of you, teachers among us, would recognize Dr. Harak Singh as the lead for the Trinidad and Tobago Mathematics Olympiad. We do wish Dr. Harak Singh all the best, and we are hoping that you are working with your students and engaging them so in the future, they will continue to be a part of the Trinidad and the Tobago Mathematics Olympiad. Continue to build their interest so that later down the road, they can be graduates from tertiary level institutions. One of them, the University of the West Indies, excelling in mathematics. And finally, International Pi Day is celebrated on the 14th of March. The date where we put the month first and the day second is 3.14. Teachers, students, well-wishers, and the entire viewing audience, I wish you all a wonderful, a productive, an exciting International Pi Day. So, as we end this session, the feature address, we look forward to what comes next. Let's hear what the University of the West Indies, the Department of Mathematics and Science, in the Faculty of Science and Technology, what do they have to tell us about their programs to inspire you to a career in mathematics following the path of your dreams? Students, all the best. Teachers, all the best as well. Thank you for listening. I turn back over to our moderator, Ms. Diyanath.
Thank you, Mrs. Harris Dutton. That was a wonderful presentation. For those of you who are just joining us, welcome to the DMS Real Talk. Remember to click on the View in YouTube button if you are viewing from the Virtual Math Fair website, so that you can ask your questions concerning the presentations in real time. So did you know that epidemiology is the study of the origin and causes of diseases in a community, and epidemiologists use mathematical models to track the progress of and the likely outcome of infectious diseases. So our next speaker is Dr. Donna Dyer. She holds a PhD in applied mathematics from Northwestern University in the USA and completed both her BSc and MPhil at the University of the West Indies, St. Augustine campus. She is currently a senior lecturer in mathematics at UWI St. Augustine, and her main research interests are mathematical modeling, applied mathematical epidemiology, and infectious disease modeling, just to name a few. Her presentation is on mathematics and its applications. Welcome, Dr. Dyer.
Thank you, Ms. Diyanath. So it is a pleasure to be with you all here today. And I was very excited when I was asked to share with you a few experiences about mathematics and its applications, because I am an applied mathematician. So applying mathematics is what I do. And one of the things that I think very important is that we start to think right from a young age, how can mathematics affect my life? What is mathematics good for? These are some of the questions that I hope to answer, starting in a very simple way. And then I want to apply it to other things, like the sciences that we offer at the University of the West Indies, to give you an idea of what you can do with it. So why should I study mathematics? What do people do with degree in mathematics? So this is what I want to talk about. Can I make a decent living? And that's something that is a very practical question. It's an important one. How is it of benefit to me? And suppose I was to choose a major or minor in mathematics, can I pair it with something else? And these are the things that I want to talk about. Why do I even need math? Well, I claim that in our day-to-day living, I need maths. You know, when I go to the grocery with a limited amount of money, mathematics comes in very handy. Taking a bank loan, it is very important because we get bombarded by all these advertisements. This is a better package, take this loan deal. Well, if I know mathematics, I can check and I can see if the interest rate that they're telling me really is of interest to me. Deciding how and when to pay off my credit card bill, that is something that as you get older becomes very important, because sometimes you can't pay it all off at once. But you need to be able to check and see how much are they going to be taking in interest from me if I don't pay it off. Making smart investments, deciding how, deciding when, and deciding where to put the little bit of money that I might have. That is important, and an important application of mathematics for daily living. Another thing, mathematics in sports. I know a lot of the young men out there like sports. Do you know that if you decided to become a coach, you need mathematics? You need to check the angle at which you throw a ball, how to head it. You need to even check and see how to kick the ball. Does it work better if I kick it at the seam? If I kick it on the side or on the front? How to hold the ball when I bowl it? All of these I can use mathematical modeling to project, to see how the ball will move through the air. Usain Bolt, such a prominent athlete for the Caribbean, he would have studied how to make that bend in the 200-meter race. And do you know that you can study that with mathematics? You know, so even things like team formation, if you are an avid football fan and you're looking to see what's going on with Manchester United, and they brought in this interim manager who has a new formation, is this 4-2-2-2? Is that a good thing or is it a bad thing? Do you know that you can answer that question with mathematics? T20 games, the cricketers among us, do you know that you need to calculate and see if I have a certain amount of balls left? Do I bat or do I block? This is a very important and it's a mathematical question. Home decoration, for the enthusiasts out there that like to decorate, well, you need to know maths to know how much carpet to purchase if I need to carpet a room, or even to figure out how much paint to buy if I need to paint. You know, sometimes we bring in workmen to our house later as you get older and you have a job to do, you need to check, because these workmen tend to give inflated budgets and we need to see if it is realistic. Are they pocketing my money, or are they asking me to build more materials than what I would need for the dimensions of my building or my house or my room? These are things that are very important for someone to know. And if you are good at mathematics, it's a very practical application. There are other very important things. If you like to eat, you need to know how to cook. And cooking is important to know how to average. I need to know how to calculate ratios, how to double a recipe, or how to divide it by 7. You know, these are important things. Sometimes I don't have the amount of ingredients that's called for in the recipe, and I need to decide how should I divide my recipe and calculate correctly. Because all of you who would have tried to make a cake, you know, if you don't have the correct ratio, your cake is not going to rise, it's going to flop. So estimating the amount of fabric for a cushion or a couch, these are other things that I need to know too. So yes, if I like to sew, I like to have nice clothes, I need to know as well how is it possible to buy the correct. So these are the things that I need to know. In terms of the, just a minute, I'm seeing here that, are you seeing my screen? Can you please just inform me if you're seeing my screen, just so that I know that for sure that you are seeing my screen. Okay, so in terms of things like cooking, right? Right, so there we are on the correct screen now. Cooking is important. Estimating the amount of fabric for a cushion or for a couch, that's important too, right? Then moving on, because what I want to really talk about is talking about the applications with respect to science, right? So this is the area that I need to really zone in on, because I am an applied mathematician and I want to talk about the applications to science in the Faculty of Science and Technology. So if I was to pick a major or minor in mathematics, what can I pair mathematics with? That is the question that I want to help you to understand. So mathematics and physics. Physics is an experimental science, and it talks about the application of science to the world around us. And there are theoretical concepts like Newton's laws of motions that are described with mathematical terminology. The main branches of algebra, analysis, geometry, all of these things are extensively used in, and you need to know mathematics. Non-Euclidean geometry, do you know what that is? Well, if you want to do physics, it is the starting point of any discussion about relativity, which is a big area in theoretical physics and subject to a lot of study at the University of the West Indies. So if this is your interest, I would suggest that apart from doing a major in mathematics, you consider physics, right? Or vice versa, you like physics? Well, why not pair it with a major in mathematics? Okay, so what else can I do? Well, what about mathematical biology? And it is very true that many of the applications in mathematical modeling today have to do with biology, life sciences, epidemiology. And you would have heard that that's one of my research interests. I actually am interested in looking at the spread of COVID-19 and other such diseases. But did you know that you could look at the mathematical equations for the spread of a disease and apply it to crime? So this is another thing, you know, there's so many things that you can look at as an epidemic. Biofluid mechanics. If you look at rivers and streams and you see these little insects walking on the water, well, that's an application of surface tension. And in order to explain it, you need to build a mathematical model, right? And it will help you to understand how creatures move in water, how they walk on water, how they move through water. So the diversity and complexity of living organisms gives a great array, I would say, an array of applications for mathematical thought. So it is also an interesting thing. If I like biology, why don't I do a major in mathematics? What about chemistry? Well, For those of you who don't know, I also am a chemist. I did a major in chemistry and a major in mathematics. And later on in my PhD degree, I studied reaction kinetics and the motion, the stability of a chemical front in a polymerization reaction. So there are several applications in chemistry. So why don't you think, if you like chemistry, you like to mix, you like to match, you like reactions, you want to work in a lab, if you're good at mathematics, then it is a very good option to pair the mathematics with the chemistry and come out with something fantastic, right? So dynamics of hard, soft materials, instabilities, changing patterns and colors, coupled oscillators like on the screen that I have here, documenting the oscillating colors inside of a reacting system. This is all something that I can study with mathematical modeling. What about computer science? Here is another application. Do you like computer programming? And did you know that logic is the basis of any successful computer program? So it is something that I could do. Mathematical concepts are key to becoming a successful programmer. So certainly, as the mathematical models become more complex, then the computing resources that I have at hand need to become a factor. So I need to then build in computer science programming. If I'm a mathematician and if I'm a programmer, I need to know the maths in order to build my computer program. So they complement each other. So if you want to do computer science, I would suggest that you think also about a major in mathematics because it pairs very nicely, complements each other. And these two fields are the basis of things like data science, neural networks, right? So food for thought. You know, one very common application that people would say for mathematics is engineering. But I put it last because I come from the Faculty of Science and technology requires mathematics. We have another faculty in the University of the West Indies, that's the Faculty of Engineering. And certainly, if you are interested in engineering, you need to know mathematics because for your design of your bridges, of your roads, which is so needed in this country, we have so much potholes on the roads. Maybe if we could build a better road, we would have less potholes. You know, so it's important that every engineer is very well versed in mathematics. So if mathematics is your strength, this could be something for you if you're thinking about a career. Improved design for aircraft, rockets, and well, missiles. I don't really want to talk about it given the scenario in the world today, but mathematics really does come in handy if you have to design something, right? A bridge, a roadway. Detailed mathematical analysis is necessary before you implement anything. So all of this, I don't have much time that I could talk, right? They told me 10 minutes. I could talk all day about mathematics, but I don't want to bore you, right? So I am just going to end with one central thought. Now, this old gentleman on the screen there, I don't know if you recognize him, but he is one of the most famous astronomers. He was born in 1564, so quite some time ago. His name is Galileo, right? He is a physicist. He's an astronomer, well, was, and also engineer, but nobody ever said he was a mathematician. And here on the screen, I have a quote. Now I have surrounded it with fireworks because I consider this a very important statement that Galileo is known for saying. And I have it in Italian, but it means that mathematics is the language with which God has written the universe. So I leave that with you, just to think about how many things I could do with maths, not just in my day-to-day life, but if I was to decide on a science career, to think that mathematics would be a very good thing to pair with whatever I decide to do. So that's all from me. And if you do have questions, you certainly can send them to the team and I'll be happy to answer. So thank you for your attention, and I turn you back over to our moderator, Ms. Diyanath.
Thank you very much, Dr. Dyer. Your presentation was definitely moving. I teared up a little bit at the end. Thank you very much. So remember to, if you are viewing the DMS Real Talk from the website, remember to click the view on YouTube button so that you can ask your questions on the live chat. So did you know that an algorithm is a step-by-step procedure to solve logical and mathematical problems? So as Dr. Dyer said, a recipe is a good example of an algorithm because it says what must be done step by step. It also takes input, which is ingredients, and produces an output, which is the completed dish. So our next speaker is also a senior lecturer at UE and is the coordinator of actuarial science degree. Mr. Stokely Smart boasts a Bachelor of Law from the University of London and a Bachelor of Science in Actuarial Science and Statistics from the University of Toronto. And he will now speak to you about the anythingness of algorithm. Welcome, Mr. Smart.
Hi, thank you very much for that kind introduction. Good morning, everyone. Welcome to my chat here on the anythingness of algorithm. Let's see, I have to share my screen. What do I hit here now? Here. Slide through. Yeah. Come on. Yeah, that's fine. All right, everybody's seeing that, okay? Right, here we go. And let me know if, as I go through, I'm going to be clicking through my slides. If my slides are not showing up, if someone could kindly, if they're not flowing through, someone kindly let me know. So, okay, so welcome to the anythingness of algorithms. I'm Stokely Smart. So, of course, let's start the discussion off on what is an algorithm, right? And this is a very important concept in the study of mathematics. So an algorithm, it's a step-by-step method of solving a problem. Now, they are commonly used for computer and mathematical operations, but it also applies to you humans, right? So for something to be considered an algorithm, it must have three important characteristics. And I'll give an example of an algorithm that human beings use in everyday life. It has particular significance in Trinidad. The recipe for cooking curry duck is an algorithm. A recipe is simply an algorithm for creating something to eat, usually something delicious to eat. All right, so if you want to look at the algorithm, let's say for creating curry duck, it must have three important characteristics. So the first characteristic is it should be finite. If the algorithm never ends, then trying to solve the problem is pretty useless. So if you have a series of instructions, an algorithm for creating curry duck, but that series of instructions is infinite, then you will never complete the instructions for creating the curry duck, and you'll starve to death before you get a chance to eat it. Right? So it's very important that your algorithm is a finite set of instructions. Right? So number two, it should have well-defined instructions with no ambiguity. So for instance, if one of the instructions, in the example that we use for creating curry duck, says add powder, but it's ambiguous about what powder to add. And instead, as a result of that, you add gunpowder or baby powder to the curry duck instead of curry powder, then of course that's going to be a problem, and your algorithm has issues. So the instructions need to be well defined without ambiguity, lest you end up with a gunpowder flavored curry duck, which of course would not be a good thing. Thirdly, the algorithm, it should be effective. It should actually solve what it's supposed to solve. So if you had an algorithm, a recipe for curry duck, but in the instructions, instead of creating curry duck, created curry pork, well, of course, that's an issue. So the algorithm needs to be effective, and it needs to actually solve the problem that it was meant to do. So where did the word algorithm originate from? Yeah. So the term can be traced back to the 9th century and to a Persian scientist, astronomer, and mathematician who went by the name of Abdullah Muhammad bin Musa al-Khwarizmi. And he's often cited as the father of algebra and was indirectly responsible for the creation of the term. So the term algorithm or algorithm are derived from the name al-Khwarizmi. So in Europe, the word algorithm was originally used to refer to the sets of rules and techniques used by al-Khwarizmi to solve algebraic equations before being later generalized to refer to any set of rules or techniques. So let's look at some examples of algorithms throughout history. The earliest evidence of an algorithm can be found in Babylonian mathematicians of ancient Mesopotamia. Right? So Mesopotamia is a region that's where current modern day Iraq is. Right? So a Sumerian clay tablet found near Baghdad was dated around, circa, just another word for around 2500 BC, and describes the earliest division algorithm. During the Hammurabi dynasty, which was around, it existed between 1800 and 1600 BC, Babylonian clay tablets describe algorithms for various computing, algorithms for computing formulas. So algorithms for arithmetic also found in ancient Egyptian mathematics, dating back to the Rhind mathematical papyrus from around 1500, circa 1550 BC. Algorithms also later used in Hellenistic mathematics. Hellenistic is just a fancy word for Greek. So for Greek mathematics, and that would have been from around 500 BC or so. An example of that would have been the Euclidean algorithm, which is used to determine the highest common divisor of two integers. The integers are just whole numbers. So let's talk now a bit about the first computer algorithm. So in the 1840s, a young woman by the name of Ada Lovelace was the world's first computer programmer. This is worth mentioning, especially given that in recognition of International Day of the Woman, which was, I think, on Tuesday, the 8th of March, we make a special mention of Ada and her significant contribution to the field of mathematics and computer science. She built on the work done by a Cambridge professor, Charles Babbage, who created the analytical engine, which was the first general purpose computer. Right? She suggested that data input, that the data that needed to be inputted that would program the machine that Professor Babbage had created to calculate something called Bernoulli numbers. The suggested data input is considered the first computer program, the first computer algorithm. Just on a side note, the Bernoulli numbers were used for creating Taylor series expansions for trigonometric functions. For those of you who might have been interested in that, but that's, we'll get into that in too much detail. Okay, so it's interesting to note, and again, it demonstrates the relevance, the significance and the importance of algorithms and their applications to everyday life, and how the significant role it played that an algorithm played with helping the Allies win World War II against the Axis powers, which of course were Germany, Italy, and Japan. Gentleman by the name of Alan Turing developed a machine to decrypt the German Enigma codes during World War II using simultaneous algorithms. So the Germans had basically a secret code that they used to transmit their various communications. That was very difficult for the enemies of the Germans, of course, the Allied forces, to decipher. It was critical, it was a critical part of the war that Alan Turing, the work that he did, was able to decrypt this code and allowed the Allied forces to be able to understand the plans that the Germans had before they actually executed the plans. So again, it was decisive in helping the Allied forces win World War II. So his model of computation is now called the Turing machine, which then became the blueprint for the development of computers. Mr. Turing laid the groundwork. He laid the groundwork for modern computing and theorized about artificial intelligence. Incidentally, when I was doing actuarial science at the University of Toronto as an undergraduate student, of course, as part of the curriculum, I had to do, you have to do a couple courses in computer programming. The first computer programming course I did at university, the programming language that we had to learn was actually a programming language called Turing, which of course was created by Alan Turing and was still in use for Sydney at the University of Toronto in back in the early 90s. I'm not too sure if it's still being used today. So let's look now at the algorithms in nature and how even in nature the algorithms appear in places that you might not expect them to. So let's ask the question, what did the pyramids of Giza, which of course are in Egypt, Da Vinci's Mona Lisa, so Leonardo da Vinci, of course, is a famous Italian painter from the Renaissance, painted the Mona Lisa, which now hangs in the Louvre Gallery, the Louvre Museum in Paris, France. And of course, the logos, of course, the logos for Twitter and Pepsi, which of course are famous logos, which I'm sure you're familiar with. So what do all of these things have in common? Well, what it is that they have in common is something called the golden ratio. And it's something inherent in the design of the pyramids, this great work of architecture, the painting by Leonardo da Vinci, and the logos of Twitter and Pepsi all have aspects of the golden ratio embedded into their design. So what is the golden ratio? So it is the solution to the equation x squared is equal to x plus 1. Some of you who might recognize this as a quadratic equation, and of course it is. And a quadratic equation usually, well, has two roots. And of course, one of the roots to this equation is positive plus 1.618033988. And of course, it goes on. And this number is referred to as the golden ratio, right? So it's one of the solutions to this to the equation x squared is equal to x plus 1. So the golden ratio is the ratio between, apart from also being the solution to this equation, it's also the ratio between consecutive numbers in the Fibonacci sequence, right? And that sequence goes 0, 1, 1, 2, 3, 5, 8, right? So Fibonacci, the way how the Fibonacci sequence works, it's the sum. You'll have 0 and 1, and then if you add 0 and 1, you get 1. If you add 1 and 1, you get 2. If you add 2 and 1, you get 3. So each number in the sequence is the sum of the two numbers prior to it in the sequence, and it goes on and on. So it's an infinite sequence. So it becomes more accurate. So the golden ratio, it can also be found in with Fibonacci numbers, where if you divide consecutive numbers, so for instance, if you were to divide 8 by 5, you will get 1.6. So if you divide the number 8 by number 5, you get 1.6. If you divide the next number in the sequence, which would have been 13 8 plus 5 is 13. If you divide 13 by 8, you get 1.6 something. And as you go further and further in the sequence, you get closer and closer to this number, 1.618. Right? So the golden ratio is embedded in the Fibonacci sequence. Yeah. So that ratio, and if you look at the four things that I referenced before, the Mona Lisa, which is this painting here, the pyramids of Giza, the logo for Pepsi, the logo for Twitter, embedded in their design is this ratio of 1.1618. And you see throughout the design of these things is something called a logarithmic spiral, which is, and I'll get to that later in my discussion. This spiral has embedded in it this number, this magical, this golden number of 1.618, known as the golden ratio. So let's look at some more examples of the golden ratio in nature. What we looked at before, of course, were human designs. Let's look at some examples of the golden ratio in nature. If you look at flower petals, the number of petals in a flower is often one of the following numbers, either 5, 8, 13, 21, 34, 55, which are all numbers in the Fibonacci sequence. All right? Faces, if you look at human faces, both, well, not only human faces, but both human and non-human faces abound with examples of the golden ratio. So for instance, if you were to take, and I actually did this, I measured this yesterday, if you were to take the, and this of course is true for most human faces, if you were to take the length of my face and divide it by the width of my face, you would get that golden ratio, that one, you get a number that is close to 1.61, and so on and so on. Yeah, you can try that. It's a fun thing for you to try on your own. See how close to the golden ratio your own dimensions are. And of course, there are other examples of ratios you can find in the human form that match your human the golden ratio. But like I said, a good example is to try and measure divide the length of your face by the width of your face. So fruits, vegetables, and trees have spiraling patterns, and the spiraling patterns that can be found on pineapples and cauliflowers, and certain types of ferns and whatnot, again, have embedded in them that sort of spiral, which has the golden ratio in its design, as part of its design, if you wanted to recreate it. Right? Shells, snail shells, the shell of a nautilus, which is a type of sea creature that has a shell, also follow this logarithmic spiral, as does the inner ear, which known as the cochlea, the inner ear of human beings. Again, follows that spiral, that logarithmic spiral, which has embedded in the golden ratio. And of course, spiral galaxies, like our own spiral galaxy, the Milky Way, and our nearest neighbor, the Andromeda galaxy. These are spiral galaxies that again follow that shape, which has embedded that ratio discovered by Fibonacci. Hurricanes as well. If you look at the shape of a hurricane, it looks very similar to the shape of a galaxy, or even some shells. And again, it also has embedded in the golden ratio. So what are some of the applications of algorithms in the modern world? Well, one example is the discipline, the study of actuarial science. Actuarial science is a branch of mathematics, a branch of applied mathematics, where you use algorithms to solve problems related to the wider financial services sector. It also has applications in data analytics. If you're studying actuarial science, a big part, an important dimension of your studies at the tertiary level will involve the study of algorithms that have applications to insurance, to banking, to risk management, so on and so forth. Yes, so very important aspect of any study of actuarial science or any other branch of mathematics. You need to have a fundamentally good understanding of algorithms. Your smartphones, all of you have smart devices of some kind. If you're here in this discussion, if you're on YouTube, it means you're using some type of smart device, either your phone, your computer, your iPad, whatever. These all the software in these devices run on algorithms, right? So you would not be able, if the fact that you're here listening to what I'm saying means that you're taking advantage of, you're benefiting from the application of algorithms in computer programming software. Artificial intelligence, again, it has applications in medicine, in search engines, in all sorts of different applications. Again, completely run on certainly the software aspect of it, algorithms. For search engines, the search engines, Google, Yahoo, even if you have Netflix or you use YouTube for playlists of songs and whatnot, all of these things run on algorithms. The algorithms that are used to basically find tunes that you or content that the search engines think that would be useful to you or that you're interested in, depending on what you're searching for or what kind of music you like to listen to. So musical composition. So musical composition is essentially just an algorithm, a series of instructions to put together noises that are pleasing to the human ear, right? So again, all of the music that you listen to, we didn't have much of a carnival this year, but all of the soca music or reggae music or whatever type of music that you listen to is basically an algorithm that puts together noises that are pleasing to the human ear. In meteorology, you use algorithms to predict what the weather will be, right? And of course, that's an area of study, that's a discipline that has developed quite dramatically over the last, I'd say, 50 years. And it saves a lot of lives because we're able to quite accurately predict whether a cataclysmic weather event is going to take place, and human beings have the opportunity to escape from the event before it happens, and it's able to save lives. So it's a very important application of algorithms. In architecture, well, we've seen an example of the pyramids in Giza and the algorithm being embedded in it to give it a particular aesthetic that's pleasing to the human eye. And so architecture, again, is just a series of algorithms to put together structures that have that are aesthetically pleasing or have some sort of structural application. So for instance, if you're building a bridge, the bridge has to, the architect designing it must make sure the bridge not only looks nice, but also works well, and it's not going to fall apart when you either crossing it on foot or in a vehicle. Yeah. So, and of course, in space exploration, the software on some of the space on all of the space probes that have gone to other planets and worlds and moons and such in the solar system, whether it was the Voyager 1 and 2 space probes or the New Horizon that went to the gas giant planets in the 70s and 80s, or the New Horizon space probe that went to Pluto a few years ago. All of these probes, these unmanned probes, operate one of the dimensions of the operation is following algorithms, following instructions that direct them on what scientific exploration they should carry out when they encounter these distant objects in the solar system. Okay, so let's now look at an algorithm for increasing the probability of getting employed. Right? Well, this is one algorithm. There are a number of them, but here's one in particular that I'm quite familiar with, being the coordinator for the actuarial science program at the University of the West Indies here in St. Augustine. So let's look at an algorithm for increasing the probability of getting employed. Right? Get a 1 or a 2 in CSEC mathematics and additional mathematics plus 3 other subjects, including at least 3 other subjects, including English. Second instruction, get a 1 or a 2 in pure mathematics and applied mathematics, plus at least one other CAPE subject. Instruction number 3, the algorithm, get accepted to the BSc in Natural Science at the University of the West Indies, St. Augustine. And the fourth instruction, final instruction, and again follows the 3 rules. It must be unambiguous, finite, and must solve the problem that you are trying to solve, complete the program. So this is a simple algorithm with 4 instructions for increasing the probability of getting employed once you've finished your, once you've left high school. Yeah. So I end the chat off today. Let's look at some of the historical, and the reason why I can back up what I said in the previous slide is I actually have some empirical data to back up what I mentioned that the algorithm is supposed to do. Again, increase the probability of you getting employed. Let's look at some of the historical employment statistics. Some of the historical employment statistics for graduates from the BSc Natural Science at UWI St. Augustine. Right. So these are pretty good numbers. I keep a database of all of the graduates from the program since the program started back in 2011. There've been about 134 so far. They've been exactly 134 so far. There's a pretty good probability given these numbers, as you can see. About 80+ % of the graduates from our program are employed in some way, either consulting firms, insurance companies, non-traditional roles, or in graduate school. Right? Over 80%. We know for certain 6% currently are unemployed, and then we don't have information on 10%. So a conservative estimate is that over 80% of the graduates from the program at the University of the West Indies, the Natural Science program at UB St. Augustine, will get employed in some form or fashion. So for the last thing I have to say, I'm going to show some information about some of the employers of graduates from the BSc in Natural Science, and there are about 36 of them, right, since the program started, and I'm going to go through and list every single one, but anywhere from we have employers anywhere from the University of the West Indies, at the Central Bank, the Answer McCall Group, the Massey Group, the Bank of America in the United States, University of Kent. So with a degree in actuarial science, where you've studied a lot about algorithms, one of the things that degree affords you is that it affords you to pretty much do anything, almost anything that you want when equipped with that degree. So anyway, that brings my chat to an end. Thank you for your time, and again, thanks for coming out and being part of UB St. Augustine's Math Fair. So I'll hand back now to our moderator, Ms. Diyanath, and again, thank you very much.
Thank you, Mr. Smart, for that very informative presentation. I found it extra fascinating that something as the golden ratio that you spoke about is present in something as small as DNA to something as grand as the
Galaxy.
Milky Way and the galaxy. So that's very mind-boggling. So remember again to click on the YouTube button if you are viewing from the website, so that you can go to the live YouTube page and ask any questions that you have there in the chat. So one of the first things a student of martial arts will notice in their training is the use of angles, common ones being 90 degrees and 45 degrees. So you may even hear the term triangular footwork. So it seems that concepts in mathematics, geometry, and even physics are important in learning martial arts and obtaining a black belt. So did you know that black belts are not only for martial arts? This was something that I learned recently. So our next speaker holds a PhD in statistics from the University of Pennsylvania and also has a black belt certificate in Six Sigma. It sounds really elite, which it is. So you can find Dr. Isaac Bialsing at UWI, and he is currently a lecturer there and teaches many courses in the MSc Statistics and MSc Data Science programs. Welcome, Dr. Bialsing.
Okay, good morning, everybody. I will try to be as short as possible because I believe that Mr. Smart and Dr. Dyer did a great job in introducing those areas. And I'll just speak about statistics and its applications. Right. So I'm just going to introduce you to some of the offerings that we have in the Department of Mathematics and Statistics as it relates to statistics, and expose you to some of the career choices that we currently have, both locally and abroad. So if you look at this slide, at the undergraduate level, when you come into UWI, there are some degrees that we have here. So the first degree is the BSc in Statistics and Economics. And I would like to think that once you decide to do statistics, then you must marry it with a subject area. So, if you're planning to do statistics, then you should think about getting into an area, being specific to an area, like economics or biology, or sociology or something like that. We also have a minor in statistics. We have some other degrees that are currently not offered, and we have, of course, these postgraduate degrees that I have down here. So what are the job opportunities? And when you hear about statistics, what exactly are we talking about, right? So when we talk about statistics, we're actually talking about all the aspects of data collection, from the collection of the data, to the storage of the data, to the analysis of the data, to the presentation of the output, right, the reports, all those things. So it goes through the entire system, right? So a lot of people just think about statistics as just, they just think about it as analysis, but it's not true. It really begins from the data collection section, and it goes all the way down to the actual final report that is written. So in Trinidad, this is where you will get jobs. So in the public sector, we have the Central Statistical Office, which we know as the CSO for short. And this office is currently being transformed to what we call the NSI. Now, the NSI is a National Statistical Institute. So so the government is moving full speed ahead in actually transforming this CSO, this old version, into this modern version. And in this modern version, what we'll have is this. We'll have a lot of statisticians, and we'll have statisticians at different levels. And not only that, because we have statisticians at different levels, some of these statisticians will be in administration. Right, so we have opportunities there. And plus, you know what, most government ministries today, like in agriculture, trade and industry, each of these ministries, they have their own statistical unit with their own statisticians, right? So, so you will have statisticians spread throughout the entire public service, not just located in the Central Statistical Office. The next thing is this. In the private sector, you will also have a lot of statistician jobs or related jobs, but you will not be called a statistician, right? So you will be called, you know, some business analyst, some data analyst, some data science, tech, or something like that. So, but at the base or the foundation of many of these jobs, you need a good background in statistics. So some of the areas in Trinidad that you could get work or you could look at work, it's in finance, so bank and insurance companies, actuarial science. This is where the statisticians, they do the modeling and things like that. In quality control, we all have factories, and within the factories we have labs, right? So we want to test these materials before they go out, right? What they manufacture, to make sure that the percentage of say glucose is actually what we are seeing on the can, right? So we have quality control people. We also have people who are engaged in something called Six Sigma, and Six Sigma is just if you look at the normal distribution, for those of you who would have been exposed to some statistics, you will see a bell curve, right? And that term Six Sigma simply means that about 100% of the data lies within 3 standard deviations of the mean. That's basically it. And there are methods in statistics, right, that are used in optimizing processes. So when you hear this term Six Sigma and you hear black belt, green belt, yellow belt, Six Sigma, what they are just methods in statistics that are applied to optimizing processes. The last one I want to mention is data science, and data science is really picking up in Trinidad and Tobago at this point in time. There is more, a lot of people are getting into it, and a lot of companies are getting into it. But at the base of data science is this: if you want to be a data scientist, then you should know some statistics, you need to know some mathematics, and you also need to be fluent in computers, right? In computer science. So before I switch to the next slide, I have to say that the statisticians of today is different from the statisticians of yesterday, in that the statisticians of today, they have to be fluent with computer software, with statistical software, but not only that, they need to be fluent with other areas of computer science, like algorithms and databases and so on. So, so these are the hot topics right now in Trinidad and outside of Trinidad, right? So, well, most of these are outside, but in data science, if you want to get in that area in Trinidad, then you need to start looking at combining or marrying mathematics courses with statistics and computer science. Those three. You have those three, you have the best package that puts you in a very good place. What are some jobs, some other jobs that we have in the area of statistics? Well, we have official statistics, and official statistics is like the statistics that the CSO produces, those reports, those summary tables, etc. That is a traditional, when people talk about statistics, they think about going out collecting data in a survey, right? And things like that, and coming back and producing tables and producing descriptive statistics and so on. That is referred to as official statistics. And we have pharmaceutical statistics, and pharmaceutical statistics is big now because of COVID-19 and vaccines and all these things, but it has always been around. So when you go to the drugstore, you pick up any medication, you'll see on the box, you are only allowed to take 3 tablets for every 8 hours or something like that, and you cannot exceed that quota. If you exceed that quota, something bad will happen to you. So what status? I like to tell people that statisticians now. So that chemical inside there, if you take too much, you'll die, right? So something bad will happen. But if you stay within the recommended levels, then it could have good effects on your body, right? So I like to tell people that statisticians are people who tell you how much poison to take so that you could lead a healthy life. So the next area is bioinformatics. This is actually a big area outside of Trinidad, and because there's a lot of big data outside there today, and we need new methods in statistics to analyze these data. We have some other areas in sports, all these online betting websites, right? We need statisticians to work out the odds, to predicting, to model football games and so on. And research statisticians, of course, exist in universities and private institutions where they look at things from a very theoretical point of view. So how do you prepare to take advantage of all these opportunities? The first one is study statistics and another discipline, right? So in order to be or considered important, right? You need to be able to talk the jargon, right? That other people are talking. So if you want to get into econ, then you need to do economics and you need to do some statistics, right? So you need to be able to talk their jargon. You must be willing to learn new things. This is very important because I've seen a lot of students, they want to get A's, but they're always looking for the easy courses, when in fact those easy courses sometimes might not prepare them for the jobs that they are looking for. And where do you start? Start with CAPE Mathematics Units 1 and 2. You must have this. This is your firm foundation that you start with at school. And always try to complement your computer skills so that you'll not be afraid in the future of improving these skills in the future. All right, so start small. So learn about Office and things like that and move on from there. Right, so that's all I have. And I want to thank you for listening. And I now hand over to the moderator.
Thank you, Dr. Diyanath, for that very informative presentation. So it's often said that mathematics is the language of science. And that means that in order to do science, like chemistry, you have to know a lot of mathematics. Our final speaker is currently the Deputy Dean in the Faculty of Science and Technology, as well as a lecturer of analytical chemistry, industrial chemistry, and environmental science at UWI St. Augustine. Dr. Terry Mohammed has a PhD in analytical chemistry and has held many positions in Petrotrim, such as head chemist and aviation jet specialist, and also worked at the Institute of Marine Affairs as a scientific officer. Like our previous speakers, these are only a few of the many accomplishments that they have achieved. So welcome, Dr. Mohammed.
Thank you very much for that introduction, Ms. Diyanath. I hope you all are hearing me well. Let me share my screen. All right, so good day, everybody, and welcome to the UWI Math Fair. This Math Fair has been going on for the past 3 years. It was initially an initiative of the St. Joseph's Convent, St. Joseph, under the stewardship of our very our very competent chair, Ms. Linda Diyanath, and UE has been working on it thereafter. So I would like to welcome you to the Faculty of Science and Technology. It is said that the future of the world is going to be based on technology. And technology is the fastest growing career option anyone can take, right? And we at the Faculty of Science and Technology see that happening every day. We do see ourselves as the future, not just of the world, but our own economy and our own technology. We are the people who are finding solutions to problems that trouble the globe. We're the people who provide environmental sciences to protect our oceans and our atmosphere, to protect our trees and our forests. We are finding ways of developing renewable energies, battery technologies. We're the people who are designing algorithms and designing networks for you to be able to network with your friends and associates or verify in any part of the globe. Because of science and technology, we've been able to continue our classes and continue all of communicating with everyone, even during this pandemic when we were all locked in our homes. Right? Science and technology is developing new materials, protecting old materials. It's everything. And it's so huge that I can probably speak all day and wouldn't even finish the applications of science and technology. Right? But let's move on. So who are we? So science and technology is a faculty that has several departments, and we're all integrated with each other. There's the Department of Chemistry, Department of Computer and Information Technology, Department of Life Sciences, Department of Physics, and connecting all of them is the Department of Mathematics and Statistics. Now, a lot of people will tell you, I don't know what to do with maths. But the thing is, maths is the one thing that is common in every single science, every single one. In chemistry, you can't do chemistry without a good background in maths. Computer and information technology, definitely. You need math. Life sciences, you need a strong background in maths. And physics, you need a strong background in maths. In fact, in order to move on to these degrees in any of these areas, you need to have maths, at least CAPE or first year mathematics. Right, so maths is actually the most critical of all sciences. And even if you're not interested in science and technology and you want to go into engineering, well, you need to have a really strong background in maths. And even if you want to go into medicine and pharmacology, you need maths there as well. So basically, there's nothing you can really do without maths. So maths now becomes the most critical area. Right? And just to tell you about us, science and technology offers about 45 different degree options and combinations, which is a very large amount. We pride ourselves in our students being very diverse. Right? They can explore several different disciplines. Dr. Dyer mentioned earlier today, she is a mathematician. She did her degree in mathematics, but she also had a major in chemistry. Right? So she's a mathematician and a chemist. Right? And our students are very diverse. They have a transferable skill set. They are very versatile. And employers love that. They love that about our graduates, because imagine if you're an employer and you hire someone to be let's say, a chemist. But then you realize, wait a minute. So they have a degree in chemistry, but they also did some computer and information technology as well. So they understand the company's network system. So they can now also not only be a chemist, they can also be a computer analyst, or they can be a network technician, right? Or they may have very good idea about quality assurance, and they may also be the company's quality assurance specialist. Or they're very good at data science and maths, so because they would have done some courses in first year and second year. So now they can even do all the company statistics and data analyses as well. So what happens is that our students provide all-in-one package for many employers, and this makes them very employable. Very, very employable, very, very versatile. But you know what it also does? If you don't want to work for someone, it also makes you a very good innovator, because you have many skills, and therefore you can start your own business. You can do a lot of work. Do you know that there are a lot of private statisticians and private mathematicians who sell their skills to various companies that allow that need occasional jobs on data mining, data protection, data treatment, statistics in order to get information to make a decision or to plan a future. They hire these people, and they don't work for anyone. They can work for themselves, and they do quite well. So employment is great, right? Now, why is maths important? Right? Well, if you look at 2 maths for dummies, $6.99 each, that would be $50. So if you were to if you didn't know math very well, that might be you. So hopefully that is not you at all, right? Math is the one skill you need to master in your life. Even if it's the only one, you will at least be able to live without being cheated, robbed, or abused, right? You see, without maths, we just cannot live or survive. We need math in our everyday life. Just doing the basic essentials is dependent on your ability to do math, right? So therefore, being able to speak the language and being able to do math are probably 2 most basic skills that you should have as a human being. And there are some reasons why mathematics is important, right? Budgeting and money are always important. Time management, this allows us to do many things at the same time. Everything in our daily lives, from shopping to doing calculations in our heads to cooking. It's fun and informative. It helps us to solve problems. Important key skills for work. It's an exercise of the brain. It means that you are intelligent. All right. And the fact that you are doing maths, it tells us that you are among the elite of students already. Imagine maths has words like logic and rational, right? So just those words alone in mathematics tells you that you're logical and you're rational. So students who always do maths are always at the top of their class. Okay. So if money is your thing, and you want to get a really good job when you graduate from university, then you should really consider math, because here's a little survey: 20 jobs for 20-somethings. 20-somethings are people who are 20-something years old and under the age of 30, right? And it shows that among the top paying jobs are actuaries and statisticians, right? And just about every other job thereafter requires a big chunk of maths. So mathematics and a career in mathematics can be very lucrative for you if you're interested in money. And of course, we're all interested in being able to have a good salary and have a decent way of life, right? If you're interested in being satisfied in your job, being able to do a job that you can feel proud of, that when you're finished, you feel accomplished, right? Then mathematics ranks right up there. In fact, a survey that was done on graduates who did their bachelor's degree, 80% of the people who did maths and statistics told the surveyors that they were very satisfied in their jobs and it was absolutely worth it. So maths does not just give you a good paying job. It also gives you a very satisfying job. And trust me, that's an important thing. And in addition to money, you have to love what you do. You have to love your job. And maths gives you one of the most satisfying jobs around. Right? So maths is the key to success. Right? In fact, maths is the key to survival. Without it, we can't do anything. So maths and hard work is equal to success. It just adds up. So on that note, I would like to end and thank you for listening. And I would like to welcome you on behalf of the Faculty of Science and Technology, on behalf of the Dean himself, to welcome you to our math fair. Thank you very much.
Thank you, Dr. Mohammed. Thank you very much for that very, very, very informative presentation. So to our viewers, we would love to hear from you. And if you have any questions for any of the speakers, you could please type them in the stream chat and they would be addressed. We may not have time to answer the questions live, but we would still appreciate if you post the questions, and we will try to give you some sort of feedback on your question on the UE Virtual Math Fair website. So I would like to take this opportunity to thank all the speakers for the time and effort that went into the preparation and the delivery of your presentation. Thank you, Mrs. Harris-Knudsen, Dr. Dyer, Mr. Smart, Dr. Diyanath, and Dr. Mohammed. And if you want more information about each speaker, you could also visit the DMS Real Talk page on the UE Virtual Math Fair website. So we have come to an end. We have come to the end of the DMS Real Talk 2022 feature of the UE Virtual Math Fair. Have a good day. Thank you very much.